Okay, so let's do everything from scratch. So let's first, of course, get our event begin overlap. We still need to detect whether it's overlapping. And we still need to do the cast. We need to do cast to third. We still need to make sure it's the third person character, so this is still the same. Make sure both connections, both wires are connected, right? This is the execution pin, this is the casting. So next, if it is a third person character, this time, instead of creating a timer, let's use a new technique, a new node called a timeline. So we search for timeline, and at the bottom we see the option add timeline. Okay, we can name the timeline node open door. We don't have to, actually we cannot do that. Why? Yeah, we can rename it, but it's not necessary. So I name it timeline underscore open door. So what this node does is basically it creates a timeline, and then it will give us the value on this timeline to drive the animation. So if we double click on this node, actually we will see a new window show up, a new tag window. So next to our event graph, if we double click, it takes us to a new tag, and this is we are now inside this timeline. Right now it's empty. Let's click on this add track button, and then we add a float track, which is the most easy to understand one. A float track is just basically, a timeline with numbers on it. So if you have done the other type of animation or video editing, this is the same. It's just a timeline from zero. From this, this is the zero. If you use your right mouse button, you can move around. If you scroll your mouse wheel, you can zoom in and out. So from the left to the right, like time move from left to right, 0 second, 1 second, 2 seconds, 3 seconds. And now we can create keyframes on this timeline. So we right click and add key to this curve float. So now we have a blue dot that we can drag around, and when we drag it around, you can see that these time and value change, right? So this is like a basic sort of like two coordinate, right? We have the time on the horizontal axis, and we have value on the vertical axis. So we can also type in numbers here. So at 0 seconds, its value should be 0. And we right click again somewhere else empty, and we add another key. This time, let's say we want the door to open fully within maybe 5 seconds, okay? So then we put the time here, 5, meaning at the 5 seconds, its value should be 1. So we use the value, always use the value, usually use the value between 0 and 1, so that the timeline can be used in many different places. So this means that the value will move from 0 to 1 in 5 seconds, right? So if we go back to our event graph, we see now a new pin. This pin wasn't here before. This is our output from this timeline that we created. It says new track 0. It's a little bit confusing, so maybe we rename it. Right click. We go back to our timeline, and then on the new track _0, we right click and rename door rotation, something like this, door rotation. So we know this curve is controlling the door rotation. Okay, so we go back to our event graph. Now we see that this pin has been renamed door rotation. Okay, so every time it updates, so the timeline basically it's like it contains already a lot of functionalities, so it will move time by itself. We don't need to use the timer like to execute a timer every frame basically, or every 0.01 second. Basically the timeline has done that. So in the update output, it will already play this timeline from 0 to 1 within 5 seconds. So here we can just say set rotation, or maybe let's drag our SM_door here, and then we drag a wire out and set rotation, and we still choose set relative rotation. And then we plug the update into this pin, and we also need to split this rotation because we only want to update the the Z axis, right? But here is a problem. Remember the timeline, we only give it a value between 0 and 1. Of course, you can say, for example, if the second keyframe, if I change the value to 100, then of course, yes, it will work. Like if I directly plug this door rotation into this new rotation Z, it will actually update the value from 0 to 100 within 5 seconds. We can actually test it. We compile and play the game. Oh, before that, we delete this old door, and we drag our new door control here. So we make sure this is the new door that we just created. I play, I walk close by, and we see that it is working. Actually, it is opening from 0 to 100. So we could say that if you are sort of a beginner programmer, then maybe you're happy with this. Result already. But usually the timelines, we try to keep it so that it's always between 0 and 1, because it's a little bit difficult to edit the value, right? Every time you need to double click on it. For example, maybe the next time after you play the game for a little while and you try to make a change, you say the door is opening too slow. You want it to open from 0 to 150 degrees within 3 seconds, right? If you want to make that change, every time you need to double click, and then you need to find this pin, and you need to change its value, right? Like 150, and then you try to change the time to 3 seconds, something like that. So it's a very difficult to edit, and also it doesn't show this value here on the node itself. So you actually need to remember which timeline controls, like what value. Like it's very complex to remember and edit. So we always, for example, use the value between 0 and 1. You can also press F. It will on the timeline. You press F. It will frame the entire curve for you. Okay. It will center on the entire graph. So we always 0 and 1 within 5 seconds. Now the issue here is that the output is always between 0 and 1 in the new rotation. So we need to introduce a new node called the lerp node. So on the door rotation, let's drag out another wire and then search for lerp, L-E-R-P, lerp. Lerp, if you hover your mouse on it, it shows that it's called linear interpolation. So it's very similar to another node that we used before, right? The f-interp. It does this very similar thing. It's also a type of interpolation. But this time, it's interpolating between two values based on another like third value. So maybe mentally it's a little bit abstract, but let's try to understand it step by step. So let's disconnect this pin first. It's not correct. So we have this the lerp node just by itself. It's trying to interpolate between between value A and value B. This is similar to our old door control, where under f-interp2, it's trying to interpolate between current and target, right? So it's the same idea here. A and B basically is just the starting value and the final value. Okay, so here we can put 0, and the B we can put 100 if we want the door to open to 100 degree. But how this lerp node interpolate between the two values is based on this third value, the alpha here. What it does is basically it maps this alpha value between 0 and 1. Remember, this alpha is like Photoshop. You have, like the alpha value, right? It's always between 0 and 1. It's trying to remap the distance between A and B within this alpha value. So when alpha is 0, it will have the value A. When alpha reach the value of 1, it will it will output the value B. When it's alpha, it's 0.5. What value will it output? Can anyone tell me? When the alpha is 0.5, what value will it output? Anyone wants to take a guess? 50, very good. Zhong Xiaoyin says it, 50, because right now the alpha value is right in the middle, right? So it will output the middle value between the A and B, right? If the alpha is say 0.2, what value will it output? I think it's now easier to understand. Hanxu, can you tell me this? 20. Okay, very good. So you understand it, right? So I think maybe most of you can understand it now. So it's remapping the value between A and B based on this alpha value, and the alpha value is always 0 and 1. So now we have another value that's between 0 and 1. Where is it? It's in our timeline, right? So in our timeline, we have this graph that's moving from 0 to 1 within 5 seconds. So now we have this. Now we can plug this door rotation and let the timeline be the alpha value. So what it does is that the timeline is moving from 0 to 1 in 5 seconds, and it's controlling the alpha of this lerp node, so that in 5 seconds, the output value of the lerp node will move from 0 to 100. It will move from value A to value B, right? So that should be clearer now. And it's the same idea. It doesn't matter what value A and B is, right? If it's between 2 to 4, then within 5 seconds, it will move from 2 to 4. Right? So you can basically change the A and B values by yourself very easily. So now let's plug the return value into this new rotation, a new Z rotation Z. Let's test this. So seems a bit too slow, right? So maybe we just want it to open within 3 seconds. So in this case, we still need to actually go into the timeline and edit the second keyframe, so that instead of at 5 seconds, let's make it 3 seconds. So it opens a little bit faster. Yep. Or maybe you want it to be even faster. You can determine your own number here. Basically, if you want it to be a faster door, that's just depend on your own interaction. Okay. So now to close the door, it's very easy now, because the timeline can play from left to right. It can also reverse. We simply need to have our end overlap node, right click, and overlap, event actor end overlap. Of course, we also need to do the casting. Make sure it's the third person character that walks away from the volume. So when it determines that our character has walked away, we simply plug this pin and connect it to this reverse pin on the timeline. So now what it does is it takes the timeline and it plays it backward. So let's test it. You walk close by and you walk away, it will close. You walk close to it, it opens. So that's it for this whole interaction. We can see that we achieve exactly the same result, but with way less nodes. It looks like a much simpler function. But and we also introduce a new concept, this lerp node. Let me stop the recording.